The HashSet is a Java collection that implements the set interface. This, in turn, is backed by a Java hashmap. And this means that elements are stored based on the hash codes. It stores unique elements, which means that duplicate elements are not allowed. Also, it does not maintain any specific order. The HashSet offers constant time performance for basic operations like adding, removing, and searching. There's a caveat though, and that's with collisions, specifically hash collisions. When two different objects have the same hash code, a collision occurs. To handle collisions, the HashSet uses linked lists, which basically is a collection of all elements having the same hash code. When performing operations, these linked lists need to be handled in addition to the normal operation, which brings a performance impact. In the worst case scenario with many collisions, performance of these operations can degrade significantly. When it comes to multithreading, additional functionality is necessary for the synchronization of concurrency. In other words, the Java HashSet is not thread safe. Alright, let's look at some code examples. I've uploaded all of these examples to GitHub, so make sure you check that out if you want to dive deeper and have a working code example. Okay, let's start by creating a new instance of HashSet and saving it in the variable names of type HashSet taking strings. Now let's add names. Let's start by Alice, Bob, and Charlie. Let's also try to add a name that already exists. So let's add Alice. Alright, so now let's check for the existence of names. Let's check if our HashSet contains David. If names contains David, if that is true, let's output a text David is in the set. And if not, let's output the text David is not in the set. Now let's take a look at this in action. Let's build and run the application. And here we can see the information about David. David is not in the set. Now let's print the number of unique names. Because HashSet only allows to have unique names, we basically only need the size of the HashSet. So let's do that by printing total names and then names.size. Now let's take a look at what this looks like in a terminal. So let's build and run the application. And here we see the total number of names is 3. Okay, now let's take a look at how to remove names. This can be easily done with HashSet's remove method. Names remove Charlie. And a little terminal message that we removed Charlie. Now let's take a look at how to iterate through all the names. So let's first print out the message list of names. And then we're going to make use of the for loop, taking the name set and accessing each name every iteration. Let's print the name. And now let's take a look at what this looks like when executing the application. So let's build and run the application. And here we can see, after having removed Charlie, we list all the remaining names, which is Bob and Alice. Now let's take a look at how to empty the set. This can be easily done with HashSet's clear method. Let's also print the message that we've emptied the set. And we should iterate through all the names just to make sure that it is really empty. So let's just repeat the section we've already done by making use of for to iterate through all the names and printing the name in every iteration. Let's build and run the application. And here we can see we've emptied the set and then we try to list all the names, but there are none left to be listed. To sum up, we've checked the basics of the HashSet. We then created a code where we added values to the HashSet. And then we checked for the existence of values. We've also removed values and cleared the entire set. And we printed all the values that we have in a set. Did you like this video? Show your support by clicking the like button and also subscribe to my channel. This way you get notified about all my future videos with topics just like this one. Anyway, thank you for watching and see you in the next video.